Hi guys, okay, question 6. We have a continuous random variable. It's defined by this. This is the PDF, the probability density function. N is an element of real numbers, n is greater or equal to 0. Show that the expected value is this and that the variance is this. Okay, show that, guys, is the command term, so you got to show it. You can't just use your calculator or something like that, right? So show the whole thing properly. We have, and I've brought these out from the formula booklet, we have formulae for the expected value of x and the variance of x, so use them. So let's start with the expected value of x. The expected value of x for continuous random variable is the integral. Now it's from negative infinity to infinity, but that's for any continuous random variable. We only have to worry about 0 to 1 because this is the only place where it's not 0. So I basically go 0 to 1 and it's x times f of x. So I do x times this, which is n plus 1 times x to the n and then dx. Now, when you multiply x times x to the n, you get x to the n plus 1. So this is just n plus 1 times x to the n plus 1. N plus 1, guys, is a constant, by the way. You could take it out of the integral if you wanted. I'm not going to bother because I'd have to do another line. I'm just going to integrate right now. So I have n plus 1 times x. Now, how do I integrate? I raise 1 to the power, so that's x to the n plus 2, because I'm adding 1 to this power, and then I divide by that new power, x plus 2, or sorry, n plus 2. Close the bracket, and then, sorry, I did a better bracket, from 0 to 1. Then I sub in 1. If I sub in 1 here, I get n plus 1 times 1. So it's just times 1, if you like. You don't have to put in that times 1 over n plus 2. And if you sub in 0, you get 0 because there's an x here. So anything times 0 gives you 0. So I'm going to put minus 0 because you subtract them, you get 0. But this gives me n plus 1 over n plus 2, which I wanted. That's QED. I've shown what I wanted to show. Okay, that's A. Not too bad. B. Variance of x. I'm going to use this formula here. It's the integral of, so the variance of x is the integral, it is the integral from negative infinity to infinity, again that's 0 to 1, of x squared times f of x. Now guys, I'm going to do the same thing, but I'm going to skip this first step. X squared times x to the n is x to the n plus 2. So it's n plus 1 times x to the n plus 2. That's x squared times f of x. And then I minus the mean squared, which is the expected value of x squared, which is this. So it's minus n plus 1 over n plus 2 squared. Okay, integrate this. So the integral of this, same kind of thing, guys. It's going to be n plus 1. Raise this power to n plus 3. And then divide by the new power, divide by the n plus 3. Close the bracket, it's from 0 to 1, and again subtract this. If you want to write it now, guys, as n plus 1 squared over n plus 2 squared. Don't forget your bracket. Okay, sub in the 1, same thing, guys. I'm going to get n plus 1 times 1 over n plus 3, and then I'm going to minus 0, which is obviously nothing again, so I'm just left with n plus 1 over n plus 3, and then I subtract this, n plus 1 squared over n plus 2 squared. And now I just need to turn this into this. I think, well, it's not that straightforward, but at least I know where I'm going. So the denominator is going to be n plus 3 times n plus 2 squared. That's already, well, that's fine because that's my two denominators anyway. And then I have to multiply this by n plus 2 squared. So it's n plus 1 times n plus 2 squared. And then this by this, which is n plus 1 squared. Let me just make this a bit longer. N plus 1 squared times n plus 3. Okay. Anything common here? Yes, I could. There's an n plus 1 common, guys. You could take out that n plus 1 if you want. Okay, let's do that. So that's n plus 1. I'm taking out it from here and from here, which gives me n plus 2 squared there, minus an n plus 1 times n plus 3. So I've taken out one of these, so there's still one left. That's basically what's happening here. And then the denominator is fine. It's already how I want it. So I just need to simplify this numerator. Okay, it's a little bit more annoying than I thought. Let me give it a bit of space here. So m plus 1 times, so hang on, the numerator I'm looking for is n plus 1. So hopefully this will just turn into 1. So open the bracket. I have n squared plus 4n plus 4 minus n squared plus 3n plus 1n, which is 4n, plus 3, lovely, that's exactly what I wanted, because this will all cancel except 4 minus 3 is 1. Same denominator again, n plus 3 times n plus 2 squared equals that minus that is 0, that minus that is 0, and 4 minus 3 is 1. So it's just this times 1, which is n plus 1 over n plus 3 times n plus 2 squared. And that, guys, is it. So I'm going to write Q, E, D. Okay, hope that makes sense. I'll see you in the next question.